Okay, so to start today, we're just reviewing the area formulas that you used last chapter, and we will be using as we continue in this chapter, okay? Chapter 10. So let's say it together. You've had a moment to think about it. If you're watching this on video, pause it, see if you can complete these, and then come back and check. Here we go. Ready? Area of a parallelogram. A equals
BH.
Good. Area of a triangle. A equals
BH over 2.
Good. Or 1/2 of base times height. Area of a trapezoid. A equals
Base 1 plus base 2. H over 2.
Good. 1/2 of base 1 plus base 2 times height. Or base 1 plus base 2 in parentheses times height over 2. Good. Area of a circle. A equals
Pi r squared.
Good. And now this one is different. This is just a single dimension circumference. It's a perimeter, right? Perimeter of a circle. So we'll use C. C equals, let's do it the short way with just two symbols. And it is? Pi d. Pi times diameter. Now, if we use the 3 different terms, we would say C equals 2 pi r. Because 2 r's equals 1 d. 2 radius equal 1 diameter. Very good. Okay, so that was just a little warm up for today. Okay, we're continuing chapter 10, section 2, 3Ds today. And you are going to receive the templates to make your own 3Ds today. So we're going to start that process today. First, we're talking about classifying solids. Then we're going to draw a few. And then finally, we'll give you the templates to start making your own little mock-ups, little solids. So to classify solids, first of all, what types of figures are these? Are these prisms or pyramids? Everyone? Prisms. Because we know that pyramids look more like the Egyptian thing, right? Where there's a vertex across from it. So if we have these prisms, the way that we can differentiate, tell the difference, is by naming them by their bases, right? So how do you find the bases? You remember? Lauren? Alberton?
We find the bases by finding which side is not rectangular.
Unless it's a rectangular prism, I guess, right?
Or unless it's a rectangular prism or a cube, the side is not a rectangle or a square.
Good. Okay, so we're looking for the 2 sides that are parallel and the same shape, right? Congruent. So, and we're going to call the prism. We're going to name it knowing what the type of base is, right? So what are the bases of this prism here? Triangle. So we call this a triangular prism. Everybody say that?
Triangular prism.
We have another triangular prism here. So you can see the 2 parallel triangles, right? Triangular prism. This is not a triangular prism. This is a prism, but it is a, what kind?
Hexagonal.
There's 6 sides here. 6 sides. Hexagonal prism. Everybody say it. Hexagonal prism. Okay? And here is that rectangular prism that Lauren was just talking about. The special thing about this prism is any side could be considered a base because every side has an opposite congruent parallel side. So if we chose this long rectangle to be a base, it has an opposite base. That's its congruent clone, right? If we chose the bottom square to be a base, it has a opposite parallel square. So the height would just be what is changing there. Anyway, okay, so let's think about this. If this is a hexagonal prism, this then is a
Pyramid.
what type of pyramid?
Hexagonal.
Hexagonal. They make it perfect so it sits on top. There you go. Okay. And if this is not a prism, then this would be what type of pyramid? Triangle. The base is a triangle. Okay. And some pyramids have bases that are squares, which I think is the case with the big Egyptian pyramids. I think there's at least one that's a big square. So we classify solids by, when it comes to polyhedra, by their bases. Now what about this figure here? What is this?
Cylinder.
Cylinder. So what is the base of every cylinder?
Circle.
Is that right? Is it circle? Yes. So do we call it a circular cylinder? Why do we not need to, Lauren? Lauren Reese.
Because it's just all cylinders have a cylinder.
Very good. So just by definition, when you say cylinder, we know there are two circle bases, right? Same with this figure. This is not a cylinder though. This is a cone. So it's just like our pyramid. It has an opposite vertex, opposite to the base. But the base of a cone is always a circle. So we don't say circular cone. We just say a cone. And we know we have a circle. But you got to remember that because that will come into the formulas that we're using. Okay? So we're going to sketch these things. So I'd like you just to write the words and then we'll sketch the items underneath them. Okay? I'm going to walk through that with you. Some of you are already, great artists and could do it without walking through. And some people like to have a little guidance, so I'll walk through them. Okay, starting with the rectangular prism. We did a little bit of this yesterday, didn't we? And you showed me a way that Mrs. Sando taught you way back in first grade. Just goes to show how long you've been doing this. The drawback for the way she showed you was there weren't the dashed lines, but that's a lot to ask of a first grader, right? But you guys are fully capable of giving the illusion of a figure by using dashed lines. So we're going to make a long rectangular prism. So we'll start by showing some face that's like the shape of a rectangle up front. So because it's really long, we want a clone of that face way back up here, but we're not going to be able to see all sides of that second base because this is a solid. So we'll see the top and the right side of that base. The other two sides we won't see. So we're trying to make a clone of the front base. Already mine doesn't look perfect. And the bottom and the left side are behind the figure, so we dash them. Because prisms have two bases, we start by drawing those bases. And once you have those down, you're totally set because all you have to do is attach the vertices that are next to one another. So we have the top vertex of the front face to the top right of the back face, right? We have the lower right of the front face to the lower right of the back. The lower left vertex of the front base, right, to the lower back is going to be a dash because it's behind the figure as I'm looking at it. But that top one, that top vertex, I'm kind of looking down on this figure, so I will see that edge. And this is not perfect, but it's pretty good. Pretty good. Okay? Anyone need help? Okay, cylinder has how many bases? Two circular bases. So we start by putting a circle, but again, we're not going to look straight down at it. If I was looking straight down on a cylinder, it would just look like a circle. That doesn't help us. I want some 3D effect, right? So I'm not going to do that. I'm going to look at it like from across the room. And when you look at a cylinder from across the room, you know the top is a circle, but it doesn't quite look like a circle. It looks a little bit more egg-shaped, right? So I'm looking from across the room at a can of soup, and I see that circle from a distance. The base of it, I can only see what is visible on the outside. The back is dashed, right? And so once you have that, we're going to attach the visible part of the base to the top, straight up. The visible part of the base to the top, straight up. Whoops. Let's see if I can make it better. Easier on paper where you don't have to worry about calibrating. Something like that. I have a bent can. Okay, one more time. Ooh, that was better. Okay. Good. Questions on the cylinder? Okay, these are fun. We're going to do a square pyramid and a cone. Now, we always, again, start with the base. So if it's a square pyramid, what's the shape of the base? A square. But again, I'm looking at it like from a distance. So I'm not going to have a perfect square. As a matter of fact, if I looked straight down on a pyramid, it would be strange looking, wouldn't it? If I put a square, you don't have to draw it. This is not the way I would suggest you draw it. But if you were looking straight down, like from a helicopter, there would be some sort of a vertex right there. Whoops. This is not perfectly calibrated, right? And then you would see an edge going down, right? Now, does that feel really 3D to you?
No.
But I mean, could you imagine it's kind of 3D?
Yeah.
Okay, so let's not look at it like from a helicopter. Let's look at it from a distance. So when we see the base, let's say we're looking kind of at a corner, it's going to kind of look like a little bit rhombus-ish. Because it's kind of in the distance. Now the fun part of making the pyramid is we know that it has one base and then a vertex across from it. So we just put the vertex first. That's the point where all the base vertices are leading to, okay? The front vertex goes straight up to that vertex. I can see this edge from the front. I can see this edge from the front, but I can't see this back edge, it's behind. And there you go. Beautiful. The cone is kind of like this. It's like the cylinder, but with a vertex opposite. So we need that base, but I do not see through the cone, so I'm going to make part of that base dashed. I keep making this a little bit undashed. And it has a vertex opposite, so put the vertex first. And then from the visible part of the cone, we draw a line up to that vertex. From the visible part of the cone to that spot. Yay, you have a beautiful cone. Okay, so I'm going to give you now a template, just 4 of the figures that you're going to be creating, okay? We're creating actually a minimum of 8 figures, and I'm missing my 1 figure right here. But you're going to create the 4 blue ones today. You're actually going to begin to create the 4 blue ones today. And to do that, you're going to get 2 blue papers. Each paper has 2 templates on it, okay? And so your job is to cut. Listen super carefully. You're going to cut, Dylan, looking here. You're going to cut around every tab that you see. All the way around the whole figure. So there will be little black lines that are visible on your cutout of this cube or of this prism. Got 4 total, there's 2 pages. Do not cut on any of the black lines and cut off these tabs, because what happens is we fold this and we fold those little tabs, and that's where you glue the cube to itself on the inside, and I'll show you how to do that later this week, okay? But one job is just to get these cut out. So I want you to carefully cut around every edge. The neater you are, the better for you when it comes to putting this together, okay? And then lightly, in pencil on the back, you could put your name in case it was to fall. I'd like you to store this in your concept book, nice and flat. All 4 figures, bring them in tomorrow. We'll be working on cutting out the other 4 figures and getting them all assembled over the course of the week, okay? So make sure that you do. If you want to keep them a little extra safe, you could take a piece of paper and fold like an envelope for them, right? And put the 4 flat figures in there and put it into your concept book where it's nice and flat, bringing it back tomorrow. If you lose this template, I'm going to charge you 50 cents for a replacement, because it costs lots of reams of paper to do this, which is costly. And I am providing you with 1, but I don't like to have to provide you with more than 1, okay? So usually when I say that, we have less waste. It's awesome. So, okay, so you also have this little assignment you see here. So why don't you get started on that, and I'll pass out the templates.